Hi, everyone. Hope you're enjoying the Data Innovation Summit. My name is Jeff Fletcher. I'm a machine learning specialist at Cloudera. And today I want to talk to you about a new framework that we're introducing for doing machine learning in production called the Continuous Operations for Production Machine Learning, also known as COPML. And we're going to talk a little bit about that today, the ideas, the concepts, and the processes behind it. But our starting point needs to be, we need to understand our definition of production machine learning. So what do we mean when we talk about machine learning in production in an enterprise context? This diagram helps you understand a little bit about what exists within data processing within an enterprise. There is a lot of the stuff that's below, that falls below the line, which is the analytics, the things that happened, the counting of things and the statistics and the analytics and the data science that has been going on for a very, very long time in an enterprise context. Then above that line is what we call the probabilistic stuff. This is what could happen. This is the predictions around things that are useful. For businesses to be able to make a prediction can be very useful from a cost containment and revenue management perspective. If you're making widgets and you want to know how often, how many widgets you need to make because you want to predict how much you're going to sell in an area, getting that wrong in terms of making too many means you have a cost that reduces your profit, but making too few means you're losing out on a revenue opportunity. So the ability to predict effectively something like that within a business becomes very useful. And this is where machine learning comes in, because machine learning has the ability to be able to help you make those predictions more accurately. But in an enterprise context, the notion of machine learning is not fundamentally the primary thing that we do. But as a practitioner myself, I often find that I get caught in this idea of assuming that what we're doing is the most important part of the business. We have articles telling us how data science is the sexiest job of the 21st century, and we have the availability heuristic. This is what we do all day, every day. But the reality is we need to be able to add value to an overall data processing ecosystem, and that we do that by making reasonably accurate predictions about how things will work. If you think about this for financial services, if your operational database doesn't work, it means transactions aren't flowing. This is a much bigger problem than the concept of being able to make reasonable predictions about whether someone will churn or not. So we need to think of machine learning as something that can help make predictions about the future in the context of a larger overall data processing platform. But getting those two things right is notoriously difficult. This diagram from the Google Hidden Technical Debt of Machine Learning Systems paper highlights the difficulty around integration of machine learning into an existing platform in order to get value from it. It's not that the machine learning part is the difficult part anymore. Many of these things have been made abstracted and made simple to be able to implement. It is getting it in production, having the data flowing all the way through, making sure that it is delivering value to the end systems. That is the complexity that needs to be dealt with. So let's take a look at what we think about when talking about a production machine learning workflow. So this is the diagram that we use, which is the most common workflow that we see. Business requirement comes in to the data science teams. They assess what data is available, then come up with a plan for this, create a few models that gets handed over to another team that will take those models, put them into production, make sure that they're accessible by the systems, and monitor them over time. And in fact, we can quantify those into 5 specific points, which is the first one is clarify the business requirements, be sure that you understand what it is that you're needing to predict, assess the available data. Do you need to add more data to it? Is the data secured? What is the PII requirements? What is the capability for that data? Come up with the plan. So you need to actually say, in order to make that prediction, this looks like an X. X might be a binary classifier or a regression problem, some kind of problem. Then deploy that model. So make sure that the model is now accessible, and then monitor and maintain that over time. So now you are monitoring and managing it all the way through. This is often cross-functional teams. So you may have a data engineering team that focus on the data ingest. The data science team are doing the analytics, the data exploration, the model building, coming up with the plan. And then the machine learning operations team is maintaining those models in production. They take the idea from the data science team and then they implement it. Sometimes your data science and machine learning operation teams are separated, but I'm seeing more and more companies start to have they're the same, but I'm seeing more and more companies that now actually separate those into two different functions. In my experience, this causes complexity around what I call the great cycle of blame. It is a procedural problem so that the interfaces between those stages can become sticking points or where things are delayed because of disconnects around internal workflow processes, because of complexities around different types of technologies. These are things that fundamentally need to be watched, because it's easy for a data science team to say, I don't have access to the data, or the data engineering team to say, you're not adhering to our PII requirements. So this is the thing to be careful of when implementing this, because workflows can also be hampered by this particular problem. All right, so let's look at this in the context of some machine learning specific infrastructure. Now, because I work for Cloudera, as can be seen by this fancy sign over here, I obviously have a very specific angle that I'm focusing on, which is the enterprise data cloud. You can rip and replace these components with other things from other vendors. Well, you shouldn't. You should only use Cloudera, but you can, or open source tools that are available. The framework that we're introducing is meant to be agnostic to the specific infrastructure, but I will call out to Cloudera components to say, this part is done by this part within Cloudera because, you know. Right. So first point is data access. In the Cloudera space, that we have the data engineering, data warehouse, or operational database components. That's where your data needs to exist and needs to be accessible. The importance here is what is available to you, and then is it accessible by the data science team? So they need to start to access that data to then start working on data exploration. A lot of this is either things like Jupyter notebooks, or something like VS Code or PyCharm, or something that has data exploration capabilities. In the Cloudera space, this is the Cloudera Machine Learning or Cloudera Data Science Workbench. And it is where you look at the structure of the data and start working on the plan for how you will be solving this particular machine learning problem. Then we need to get into model building. Often works in similar basis, but you might use something like Streamlit or again, Cloudera Machine Learning to be able to implement the model building. So this is where you train the model, do your first runs, you do model optimization. You might use AutoML here to get the best version of a model, but that is where you start building the model for the first time. Then we need, and what we end up with is an artifact. So this is a binary file that you will be able to use to ship into different locations to then deploy. So the formats that we have is pickle files, probably the most common. This is what comes out of scikit-learn and the like from Python. You would have models that based on TensorFlow. You would have Spark ML writable models. There are text markup languages that try to encapsulate the concepts within it. I don't see them a lot in terms of customer implementations. You might get them maybe at a few edge cases, but PMML and ONNX are known entities, but they're generally not used. It tends to actually be the final binary artifact that people are using. Then we need to actually train the model. So now that we've built it for the first time and optimized it, we need that ongoing training process. If you're getting in data more frequently, you need to have a mechanism that is training it on an automated basis. So it's not a person choosing to train it, but it just is happening on its own. Again, within Cloudera, that can use our data engineering or machine learning capabilities, but this tends to be like workflow based. So something like Airflow or Kubeflow would be where you would work with this on. It's worth thinking about the concept of where you want your workloads to run at this point in time. Let's say it's a neural network-based model, something that's doing like visual processing, and it's a huge amount of data, and it's a very big model, but you only need to train it once every 6 months, then cloud infrastructure would make the most sense, because you don't want massive amounts of GPUs that sit idle on-prem doing nothing else. But maybe you're doing a linear model that's being trained constantly, in which case doing this on-prem is going to make sense in the context of the economics. So there are other factors that come into it. Are you allowed to use cloud? Do you have to use cloud? Are there PII requirements? Whatever that may be. But you have to think about the context of where that training is going to run and what's going to make most sense in your implementation. Maybe you have a hybrid model. Maybe you do some training on-prem, some training in the cloud. But you need to think about that in the context of the process of the model that you're building. Then we need to package, deploy, and serve these models. So we need to actually put them into production. There are two modes of operation that we see. There's either batch mode, so that is something that runs against a large data set and updates reasonably frequently, or it's real time. So it's something that you need to, in a shorter space of time as possible, make a new inference on a particular data point. From a Cloudera perspective, we focus on both of those. So we have both of those capabilities there. You just have to think about your particular requirements. And then we need to monitor these models. And now this is, if you take one thing away from this talk, it's that we tend to focus so much on the statistical metrics around monitoring and not enough time on the fact that you need to have a business value that's also a lever that's being monitored. You have to understand that you're implementing something that has to add value to the business. And if all that you have is the cost of the team and the infrastructure being deployed with no metric that tracks back to this is beneficial to the business, it's going to look like it's not useful. And it may eventually lead to a failed project that was a perfect technical implementation. So we understand not just that there is an underlying metric that you're measuring for the performance of the model, whether it's accuracy, whether it's mean squared error, whatever it might be, but there also needs to be the business component, because that is what we will be judged at later, is to say, did this team and did this infrastructure actually add material value? So in terms of that context, we understand this is a workflow. These are the bits and pieces that we need to address for our workflow. How do we understand this in the concept of our framework? Which is where we get to the idea of this framework, which is the continuous operations for production machine learning, COPML for short. The first question that a lot of people will ask is, well, why don't you just use continuous delivery? Continuous delivery is good, and there is actually a continuous delivery for machine learning that exists. I have taken components of this, and when I say I, it's myself and my colleague Ade, who have spent a lot of time working on this particular project and then on this framework. The difficulty with continuous delivery is it focuses on releases and it focuses on people. Whereas in the context of machine learning, there's a lot of loops that happen that are being automated. Machines are making choices to go and retrain things. And you have to think about their life cycle in the context of something that's constantly evolving, rather than when you need to bring a person into the process. And there are also metrics that are measured that's not just an utility. You're not bringing about a feature request. There may be something that changes in the data landscape that causes this to happen. So there's an expansion on some of the concepts of continuous delivery, but there is also the idea that data scientists are that. They're data scientists, not necessarily software developers. And software development life cycles have different inputs and impetus and capabilities with regards to the practitioners. So we're trying to focus this to be a little bit more friendly around the teams that are there and the processes and mechanisms that automate and change how machine learning works to make it different to software development. So we have our process, but what do we need? What are the requirements for this? So when you put the requirements, we want a machine learning process that has the following capabilities and requirements. You need to understand availability, effectiveness, automation, risk, auditability, reproducibility, and explainability. And I'll unpack each of these, but let's start with examples. So there's two scenarios, and these are made available inside the Cloudera machine learning platform as fully deployed AMPs, we call them, so applied machine learning prototypes, that lets you take and deploy the end-to-end projects, all of the artifacts, all of the workflows and documentation around this to understand how it works within our infrastructure. You can take these same projects and map it to other infrastructure. You shouldn't, but you can. And the scenario one is customer churn, which is I'm a telco. I have a bunch of customers that are leaving me to go to a competitor. I'm trying to identify the people who might leave, so that I can initiate some form of mitigation strategy. So it's a binary classifier problem. And this is to help the marketing team identify the at-risk customers and retain them. The second one is chest x-rays. So trying to determine whether someone has pneumonia or not based on a chest x-ray, also a binary classifier. but it changes a lot of the requirements because in churn, no one's life is at risk. So the business processes, the regulatory requirements will be quite different. And we will discuss these in the context of each of those projects as we go. So we have a specific set of requirements and we've already labeled them, but there's two high-level categories for these. There is the first, which is the business requirements. The business needs to have a model that meets the availability requirements, has an effectiveness, it is automated and reduces risk. And we also have regulatory requirements, which is that the regulators and laws will require us to have projects that are automatable, reproducible, and explainable. To point out that this presentation is backing for a very long document that comes with this, which we will be publishing early November, I believe. So there will be a lot more detail that will be available from this. So you can get hold of me or ask my colleague in the Q&A session after this as to how to get access to those details. But we will delve into each of these. But at a high level, these are the things that you need to think about from a process perspective, and then make decisions around what you're going to do with regards to each of those sections. So for availability, for a churn model, if I'm a day late, it doesn't matter because it's just simply churn. Whereas for an X-ray, you have to have that model available. So you might need to put in infrastructure that has replicas, that has multiple versions of things. Sorry, if you can hear a noise in the background, it's my dog snoring. She's not as interested in machine learning as the rest of, hopefully you are while I'm doing this talk. So availability is the context of understanding how available it needs to be. If someone's coming to the hospital, you need to have that model available. Churn does not. So your architecture in terms of your infrastructure that you need to put in place will be determined by what you consider the availability for this particular model. Effectiveness, I think, is problematic in the context of how we view machine learning and AI from an industry perspective versus the reality here. Very few enterprise contexts require that you beat a world champion at a board game. Like most of it is about making sure that you're putting a product in front of someone so that they will buy it, or that you're trying to work out who is and who is not leaving you. Effectiveness is driven by the ability for the machine learning model to meet the business objective. It's not about how accurate the model is, it's about how good is it actually at helping you reduce churn. So those are the measures that we need to say and put in place to say, how are we determining how well our machine learning project is working in the context of what the expectation is from the business, which is why one of the first steps is clarifying the business requirements, because that is going to be the effectiveness measure by which this project will be judged. At the same time, we also need to understand the statistical components so that we can make the correct call with regards to how things work. Then we need to get into automation. As many of these things that can be automated as possible should, because your data scientists should be working on models and plans. They should not be spending time doing repetitive tasks that can be run via automation. Data ingest can be automated in Cloudera. The Cloudera data engineering process is very good at data ingest and automation. And within the Cloudera machine learning data service, we have the ability to automate things via jobs. So you can automate training, you can automate model deployment and redeployment, you can automate model monitoring. These things are automatable. What you can automate, you should. In the context of the churn project, this can be done by data ingest, standard Spark jobs that just go and grab the new data and put it in. In terms of the X-ray project, you also need some kind of automatable function, but it may happen less frequently. But you need to think about what you can automate, and you must automate what you can. Then we get to risk management. Risk management is around the business risk and reputational risk for the company that the model may cause by getting things wrong. If you predict someone will leave and they don't, it's not a big problem from a churn perspective. If you predict that they don't have pneumonia and they do, it is a much bigger problem. So risk management requires understanding the notion of bias, understanding the potential risk of choosing the right metrics. So do we set specificity to the correct levels so that we're making sure that we get fewer false negatives through the through the X-ray model. This is a question of managing risk. You need to assess the potential risk of failure and the potential risk of inherent bias in your data with regards to each project, and then mitigate that by either bringing in someone external who can understand if you have bias in your data, how you can reduce the risk for the company around that. So that's the business requirements. The next step is the regulatory requirements. So in a European context with GDPR, if you make a fundamental decision about someone's life that affects them materially, you might be subject to these requirements. Churn has fewer requirements because it doesn't necessarily materially affect someone's life. You're not making a decision around their ability to, say, get access to insurance, or making a decision as to whether someone does or does not have pneumonia. So the levels that you need to go to and whether you can enable or disable certain features in Cloudera machine learning, auditability is based on a thing that we have called model metrics. You don't necessarily need to run model metrics when you're doing churn, but you can. So this is a decision that you need to make at the outset so that you deploy your infrastructure correctly. Auditability is the idea of this was the call that was made to this model, and this was the response. And the model we used was that model, and this is the data that it was trained on. So we have a full history and picture of things that happened historically. In Cloudera, we do this with something called Apache Atlas that kind of builds up all of that process for us, and it creates what we call the lineage. From the lineage, you can also get reproducibility. Reproducibility is the ability for someone else to be able to recreate and get those same results. You want to know that when you're training a model, at least within a minimum acceptable margin of error, you're always going to get the same results from those models. If you predict that someone doesn't have pneumonia and they do, and something happens to them, this is the reproducibility you would need to be able to deal with the legal consequences to say, here's the data, this is what we trained it on, this is the result, and there was an error in the model training. Well, the error was acceptable error within the model training parameters. If you can't reproduce it, it's possible that you made an error, in which case there is a bigger consequence for the company involved. So you need to be able to understand reproducibility. And do you need reproducibility? If you don't, in the churn context, you don't necessarily need to have entirely reproducible data. You don't need to snapshot. You don't need to implement mechanisms to make sure that you can recreate that. So on a per machine learning model basis, you can decide the requirements for reproducibility and auditability. Included in this now is the idea of explainability. And GDPR has a specific requirement that if you deny someone something like an insurance process, you have to explain why. With complex black box models like neural networks, it's difficult to understand the inherent components to this. So there are techniques that implement explainability like SHAP and LIME. We have a report from Cloudera Fast Forward Labs that does a deep dive into this topic specifically. But explainability is a component that you need to understand. Is it a requirement for your model that I may have to explain to someone later? If this is a requirement, you have to include it as part of your development process so that it can be integrated into the overall workflow, so that when you update the model, you also update the explainability components. So that gives us our end-to-end view for the Cloudera for COPML. So for continuous operations for production machine learning, we focus on processes and techniques and ideas that help you make it so that it covers all of the requirements with regards to availability, effectiveness, automation, and risk from a business requirements perspective, and then auditability, reproducibility, and explainability from a regulatory requirement perspective. What we're hoping is that this framework will help guide a lot of the decision-making and processes that you follow internally to make sure that the machine learning models meet the requirements that the business has and that the regulation has, and that also deliver value to the business. Alrighty, so thank you all for your time. If you have any more questions, my colleague Chris will be on the call for a while to help answer some questions. And yeah, I hope you enjoyed this. If you want to get hold of me, you can grab me on LinkedIn. Just look for Jeff Fletcher at Cloudera, and I'm happy to help with anything further.